Hello class, this is my presentation for today. I'm gonna share the screen. So my presentation is titled Predicting the House Prices of Unit Area. And we're going to use the real estate valuation dataset. Problem statement involves predicting the house prices based on select number of independent variables. And I'm gonna explain these variables in the next slides. This dataset is from the market. For that market, there is New Taipei City, Taiwan. So the data is sourced from that market. Again, the title of the dataset is Real Estate Valuation Dataset. It's sourced from the UCI Machine Learning Repository. It's a sample of 414 houses collected in that market, New Taipei City, Taiwan. It's collected between 2012 and 2013. It details houses, transaction dates, when they were bought, age, location, price, distance to the nearest metro station, and the number of convenience stores close to the house, close to a given house. So I have 3 research questions and hypotheses that I'm going to test. So my primary research is to predict a model, is to establish a prediction model for house prices in that market, in Taipei City. The method that I'm going to use is regression. I'm going to test also, so my second research hypothesis is I'm going to test Chen's claim that the average house price in Taipei City in 2015 was $20,667. And the method that I'm going to test this claim to see if we're going to reject, if we're going to reject or fail to reject the claim, we're going to use the t-test method. The last research question, we're going to create a model that determines if a house is fairly priced or if it's overpriced. And the method we're going to use here is decision tree classifiers. We're going to create a decision tree classifier model. So data cleaning analysis. So we have our data set. So the software that we used for cleaning and analysis is Python. Primarily Python, also use Excel, but primarily we're going to use Python. And then a new column that holds location clusters or location groups is created by clustering the longitude and latitude variables. The outcome is 2 location clusters, and that is based on the elbow method that helps us determine the number of clusters that is optimal to extract from a certain number of variables. So optimal number of variables based on the elbow method was two clusters. So from that we extracted 2 location clusters and we created a new column that is called location cluster. So each house either belongs to the first cluster or the second cluster. After that, we drop the longitude and latitude columns, and then we drop all missing value columns. That's data cleaning process. So as you can see, the elbow method curve over there, the WSS curve, you can see that the elbow starts taking a steep slope after 2 clusters. So that means, and when you look at this next chart, you can see like approximately from a scatter plot of latitude and longitude, we have approximately two clusters. So we're going to group these houses into 2 clusters. So now, to answer our primary research question, we're going to identify the independent variable. The independent variable is going to be house price. That's what we want to predict, the house prices. And then the dependent variable is going to be the house age, location clusters that we just created, the number of convenience stores, and the distance to the nearest metro station. train and test on our data, we're going to use the train test speed function Python. So the Python is going to randomly select 80% and 80% sample from the primary data set for training the model and 20% for testing the model. And the result was a 51% coefficient of determination, which is not that strong. So it means that prediction model is not as strong, but it's still optimal. And also the model training score based on the 20% training set that we random set is 71.53, which is not as strong, but it's still good. It's not excellent, but it's good. For the research hypothesis number 2, we're going to test Chen's claim that the average price of houses in that given market was $20,667. So since that statement contains since that statement is the statement of equity, that's going to be another hypothesis. And thus our alternative hypothesis is going to be the average price in that given market is not equal to $20,667. The test that we're going to use is the two-sided t-test with a significant level of significance of 5%. Our result, as you can see, the p-value is significantly less. The p-value right here is significantly less than the level of significance of 5%. So that means we're going to reject Chen's claim. Research question number 3. So now we're gonna extract a new column titled fair. It determines if a house is fairly priced or if it's overpriced. So if it's fairly priced, it's going to be denoted with the value 1, and if it's overpriced, it's going to have the value 0, that column. And how are you going to determine if it's fairly priced or overpriced? So you have to do some data cleaning and data analysis. So first, we apply the regression model that we created in the primary research to ascertain home values. And then the values are compared to respective prices that we already have in the data set to determine if a house is fairly priced or if it's overpriced. Now, to create our model to determine if a house is fairly priced or overpriced, our X value array is going to be the fair column that we just created. And then the Y values are going to be the house age, distance to the nearest metro station, number of convenience stores, and location clusters. And we're going to use the same train and test model as we used in our last research hypothesis when we tested our last research hypothesis. And this model had a whopping 84.3% score. I mean, when we trained it and then when we tested it with 20% random sample, the prediction score of that model is 84.3, which is very strong. It's a very strong model. So our final conclusions, this is the prediction model of house prices based on those select number of independent variables. And also there's sufficient evidence to reject the claim that the average house of unit area in that given market is $20,667. The decision tree classifier appears to be a strong predictor of if a house is fairly priced or not. And that's based on the 84.3% model score. Application. This aids the prediction of house prices, and that's the goal. Actually, that's the goal of this analysis. But also, the test score was not that good, so it would have been better. The model can be improved with more data. You just have 400 or so, give or take, houses in that data set. So if you had more data, we can strengthen up the model. And we have more variables in place. So there's a lot of missing variables. So like security, there's no variable that pertains to security in this given data set. Or if we have a variable that pertains to the number of schools, the quality of schools also that are around, repairs, maintenance, and all these things, they're missing the data set. So if you have more variables and more data, we can strengthen up the prediction model. And also the classifier, the classifier which determines if a house is fairly priced, can be used to back investment or purchasing decisions. Project reflection. I learned the application and practicality of different analytical and statistical methodologies, like classification and all those statistical methodologies, regression, multiple regression. The challenge of which was also a learning experience was how I had to independently explore different analytical tools and models in Python, and also like in R, there's a lot of models that I had to explore independently, which is also a challenge, but also I got help from the professor and my fellow students or fellow peers, and it was really a learning experience for me. And also it sparks that fire in me, so I can improve those skill sets that I've been exposed in this entire course moving forward. These are my references, and I will thank you for listening. And if you have any comments, please, you can write them down at the comment section.